Welcome to Lesson 8 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to look at our SQL database design. Originally, I had planned to go into logic design directly and assumed that you understood where the data came from. But after thinking that over, I decided that we should at least look at the design and structure of a database and then go from there. You could consider this a bonus video since it's not really about the C# project, but it is kind of important to understand if you're going to build this on your own. Now, if you aren't familiar with SQL, this video isn't going to be a comprehensive overview. I'm actually developing a start to finish series on Microsoft SQL databases that should be out shortly if it's not already. Instead, today I'm going to walk you through some of the basics on how I built this database. Everything is scripted out, so if you purchase the upgrade for the course, you'll get all the scripts along with the items in the package. So let's jump right into our diagram. So here we have our database diagram, and it looks a little complex, but don't worry, it's not that complex. What this is just showing us how all the different tables relate to each other. And I bring this up not to scare you away or to just confuse you, but instead I want to point out a couple of things. Again, I'm not last name is Corey, and my email address was tim@corey.com. But then somewhere else in the database, it said Tim Corey, Corey@tim.com. Which one's right? It's hard to see. And so this setup right here tries to minimize duplicate information by always using IDs instead of the actual person or actual object. So just note, whenever we try and store information, we try and store it in as tight a formation as possible, meaning we don't have as more columns as we need to. For example, if I were to say, you know what, we're going to have at least one, but maybe 5 email addresses for people, I wouldn't add 4 more columns for email address 2, email address 3, email address 4, and so on. Instead, I would then create a new table over here called email addresses. And then I'd have a column for person ID, which would be this right here, and then a column for the email address. And that way one person could have 1 email address or 5. But in this case, I'd say, you know what? We're only going to capture 1 email address and 1 cell phone number, and that's it. So therefore, it makes sense to put them here so we don't make our database design more complicated than it has to be. And that's the balance we always play with when we're developing a database design. So this is it. This is our database design. It should hold all the information we need. So we have the tournament information, the prizes, the entries, the teams, the matchups, the matchup entries, the team members. That should be basically what we need for our entire database. But, especially when you're designing these things, not really on the fly, but you're designing as you go, usually you forget something. And so I'm actually building this course in a way that takes you through those kind of decisions. So that when we get down the road, you might find out, oops, we didn't include something. How do you put that in? Because that's real world. The real world is you never get something fully planned out before you have to put it into code. And so how do you take those modifications after the fact and put them into place? And so we'll do that with this database as well. Now let's turn it over to the SQL Server Management Studio. And that's here right now. Okay, so this is the SQL Server Management Studio for Microsoft SQL Server 2016 Developer Edition. Now, what I love about this is the Developer Edition is free. You can go to Microsoft's site and download it. But yet, the Developer Edition has all the same power as Microsoft's Enterprise Edition SQL Server. Now, Enterprise Edition is really expensive for a developer or a single person to buy. But we don't need to put anything in production, because that's the one limitation this database has, is we can't use it in production. But for development purposes, it's free to use. So if you were in a corporate environment, you could develop in this and then push the changes to your quote-unquote real production server without an issue. In this case, we just need something for testing and for developing our application. And this will work just great. If you're not familiar, over here on the left, I've connected to my instance of SQL Server. You can actually have more than one instance of SQL Server on your machine at any one point. In fact, this right here is the ./SQL 2016 instance, which means that it's not the primary or default instance on my machine. Typically, the default is just the dot. And so this is actually the named SQL 2016 instance on this machine. And the reason why is because I also have an instance for all of my work development, which of course I don't want to give away to the world. So in here, I have one database, the Worldwide Importers database. That's actually from Microsoft. They give you a sample database to play with, and you can download that by Googling it, Worldwide Importers Sample Database. But today we're actually going to create our own database. Now, there are a couple ways of doing that. First, you can right-click on Databases and say New Database. And it brings up this dialog and has a whole bunch of options here. But here's what I find, especially for a development machine. You don't need to deal with all of this stuff. Okay? Now, you could just fill in a name here. So if you wanted to, if I typed in tournaments and hit OK, that would use the defaults for everything. Now there is here, this is the actual data file. And so you can set some defaults here, like the initial size, how large it will grow, at what size, and to what maximum size, and then where that's located on the disk. Now, if you're actual DBA, you'd want to change this path location because you want to get the most speed you can out of your disks. And so typically what you do is you'd put your data file, this right here, the data file, on one drive, and then your log file on a different drive. Now, we're not going to do that today. We're not going to worry about any of those kind of defaults because this is just for development, not for production use. Now, that's one way of doing it. You just hit OK, you're done. But I'm going to show you a different way. If you go to New Query, this right here is the query window, and it's the place where you should probably spend most of your time as an entry level or even through advanced SQL developer. I find that it's much, much quicker just to do things here than it is to try and mess around with the GUIs for most things. And I'll show you an exception in just a minute. So to create a database, you simply say, and I'll tab down here, I'll say create database tournaments. Now notice the semicolon at the end. That's one of the newer things in SQL Server, and by newer I mean I believe it came in around 2008 maybe. So newer as in 8 years ago probably. But it's something that is usually left off by developers just because we forget it. But it really should be added to the end of every statement, not the end of every line, the end of every statement. So create database tournaments. And if I hit execute, that says command completed successfully. This message window down here is where you see the results when you have results. You come back over here, you don't see the database yet, but if you hit the refresh button when you're on databases, it now shows the tournaments database. And if we open that up, you'll see database diagrams, tables, views, and all the rest. And if you open up tables, there's nothing in there. That's because it's a blank database. Let's go ahead and change that. What I'm going to do is I'm actually going to run all of my table scripts, since running scripts is really boring. But then I'll come back and show you how to create a table, and then also how to create a table script. I'll be right back. And I'm back. Okay, so I've created now all the tables using my script that I will need for this database. Now let's take a peek at one of them just to see how a table is constructed, and then I'll build a sample table for you just to show you the process that I go through. So let's look at prizes. I'm going to right click and go to design. And the nice thing about the design view is it shows us an editor for editing our tables instead of having just the SQL script. The SQL script can be a bit daunting. In fact, let's go ahead and look at the SQL script for this prizes. Standard that I have. You don't have to have that standard, but I call it ID, and then anywhere else I typically call it prizes ID. So that's an integer column. That's the data type. So these right here are data types. That's what you're familiar with when it comes to SQL. It's just they're named a bit differently. So my ID column is first. It's of type int. It does not allow nulls, meaning you have to put a value in there. And then this key right here indicates that's the primary key. And the way you mark that as a primary key is over here, you'll see this little key icon. And you click that to add, or in this case, remove the primary key from that column. And what a primary key does is it says, this is what we're going to order all the rows by. And why this is important is it allows SQL to optimize the database or optimize the table. If we don't have this, SQL does what's called a heap. And it's basically just what it sounds like. It just throws rows on top of the heap. But then every time we want to look for a row, it has to go sorting through that heap as if it was a garbage dump. Now, this is a key that we create. And in fact, this column right here, ID, I set as an auto incrementing column. If we zoom out here and come down here, I'll pull this up, and down here in the identity specification for this column, we have, yes, it is an identity, and the identity increment and seed. The increment is how many we count up by. So in this case, 1. And the seed is the starting number. So the very first item is going to be number 1. And the next one will be 2, and then 3, and then 4. Which makes sense. We're just going to count up. But what that does is it gives us a unique identifier for every row in our table that SQL will sort by. That also means when we add a new row to our table, it knows immediately to add it to the bottom of our table because it has the highest number. You see, there's a lot that goes on behind the scenes when it comes to a table and how it stores information. And we want to make sure that we optimize our tables for most efficient storage and retrieval. And this seems to be the best way of doing that, creating this ID. Now, there will be obscure edge cases where that's not the case. But, and here's the deal, you're a C# developer, probably. If you are, and you're building databases, it's not because you need to build the most totally optimized database on the planet. You need to build a good, really good database. And this is the way of doing it. If you have your SQL developer friends say, hey, this is a much better way of doing it, which there isn't a much better way, but maybe a little better way of doing it, tell them, great, go ahead and build one. But this is the way that gets you the 98% of the way towards optimized for about 2% of the effort. So go ahead and do that. The next thing is the place number. Again, it's an integer. That's for our prize, it's going to be first place, second place, third place, but just the number. So 1, 2, 3, 4. Again, we don't allow nulls. The place name. Now this is a little bit interesting here, and I want to point this out for a minute. This is where you put the place text. So first place, FIRST space PLACE, first place. So we need to have a text field of some kind. In C#, that'd be a string field, real simple. But in SQL, where it's all about data, we have to optimize for what type of string do we want. Now, $50 characters. Now it can't hold 51, but it can hold 50, 49, 1, or even 0 characters. That's what the variable means. The counterpart to that, it does not have the var there. It's just nchar or char. And what that does is it says we'll always have 50 characters, whatever that maximum number here is. And so how it gets away with that is if you store, say, a string of 5 characters, it's going to pad that string with spaces afterwards. So it's going to have the 5 characters you gave it plus 45 spaces. All right? And there are times when that's useful, but typically I find that it's not useful, again, for about 95% of the times when I want to store text. So I always default to varchar or nvarchar. And that brings us to this n. The difference between varchar and nvarchar is the type of characters it can store. A varchar, without the n front, can store just the typical ASCII characters. But the nvarchar stores Unicode characters. Now, Unicode takes up twice as much storage space in your database, but the benefit of it is that it allows for other languages' characters. Now, I'm in the US. I typically deal with US English characters, and so if I were dealing with just US characters, I would do varchar for practically everything. But if you are dealing with an international audience, or you're dealing with the option to have international characters for certain things, you want to have this nvarchar. And so that's the difference. You'll see me use both kinds in this database. And that's because of whether I thought that I would be providing the strings or the end user is providing the strings and what type of strings they are. So that's the decision to make because it does, again, double your storage capacity or storage space taken up by this data. And when you're getting into millions of rows, storage space is important. Again, we probably won't get a million rows in this project, but you know what? You want to plan for as optimized as possible right up front. Best practices. Okay, so we can change this number here if you want to, up to, I believe, 4,000. But there's also the option here of nvarchar max. And that's a bit different. Max will hold a ton of data. It's actually handled a bit differently than the nvarchar because that max data is not actually stored with your row. Now, when you access it and use it in the database, it's connected and it doesn't look like it's any different. But in the back end, it's actually stored a little bit differently in order to allow for some optimizations. And that the max field will be for when you're going to allow the user to type a book. I mean, lots of information or other types of data. One of the places I use that is if I'm storing a JSON string in my database to be used in my friend web application, I'll usually do an nvarchar max. That way I can store a very, very large JSON string without a problem. Okay, we have the prize amount. Now, just like C#, where we have the decimal versus the double, in SQL we have that same differentiation. So the prize amount is dollars and cents if you're in the US, and probably something similar, or at least as similar as far as the actual numbers is concerned in other places in the world. So we have what's called a money column. And that is that precise column, that decimal type in C# is probably the closest equivalent. But then down here I have the prize percentage, which is just a percentage. Think a number between 0 and 1. So, 0.28, 0.83, whatever. Therefore, that is a float. And that's the equivalent of a double in C#. So that's a table. That's how you create it. There's a few more things to look at. The biggest thing is the relationships. So back on the diagram, we saw that the tables were all kind of connected to each other based off of these ID numbers. And in fact, if you remember back in the diagram, or if you have the companion booklet, you can back and flip back to it. We have this ID field right here, the prizes ID, connected to the tournament prizes table. And how do we do that? Well, right up here, I know it's kind of small, but let's zoom in here. This icon right here, it says relationships. Now, if you're dealing with a previous version of a SQL Server Management Studio, you'll see the icons are a bit different. In fact, this used to be a yellow icon. It might still be. Nope, it's not. So it used to be a yellow icon, but it's not anymore. And this is a little bit different. But if you mouse over it, it says relationships. It's the same one. So we're looking for relationships here. And we get this. This is our relationships editor. So what we do here is we say these two tables are connected. In this case, we have one relationship. We have the prize ID to tournament prizes table relationship. And if I come over here to tables and column specifications and click the ellipsis, all right, the foreign key table is the tournament prizes and the column is prize ID. The primary key table is the prizes table and the column is ID. Now that's, again, terminology is sometimes difficult to get through, but think of it this way. The primary table is the one that actually has the quote-unquote real ID. That's the ID we just created that says this is the unique row. Okay? Think of it as row number 5. How does that relate to the tournament prizes table? Well, in the tournament prizes table, there may be more than one entry that has 5 for the prize ID. So therefore, the tournament prizes table is the foreign table. So primary is the one that has it just as ID. That's the primary table. The foreign table is the one that uses that ID. So what this does is it links these two columns together and says, okay, these two columns are related. They're the same data. So when I say 5 over here, I mean the record over here in prizes that has an ID of 5. Now you can get into some really fun relationships. I didn't in this database, but what you could say is enforce replication. And you can say what happens when an insert or update happens. So I could say if I delete an entry, what happens? I can cascade that delete. And so what that'll do is it'll keep my two tables in sync. For example, if I delete a prize, then I shouldn't have that prize ID used anywhere. And so I can replicate then, go ahead and delete all the records where 5 was used. Or I could set them to null or default. And the same thing with update, I could update the information here. So for example, if I were to change the ID in the prizes table, it would then update everywhere it said 5, it would now have a new number, which don't change your IDs. Let's just get down to the bare facts here. Don't change your IDs. Think of them as unchangeable. Okay, so that's relationships. Tell you what, let's go ahead and close this out and create a new sample table. Again, we could do the create table right here, like that, and keep going, but that's really complex and not something you need to worry about. Instead, right-click on tables, say new table, and then just start filling it out. So I start with ID. I apologize, this is so small. Not much I can do with this editor right now. So I say ID, and then I choose int for the type, and uncheck this allow nulls, and come over here to the set primary key button to add that as a primary key, and then expand down here the identity specifications. I double click on the no of is identity. Setting that to yes also changes these two to the default values of 1 and 1, which is exactly what I want, so that's good. Now let's create a table that stores, I don't know, person information. So let's create a first name. No spaces in the column names. Don't do that. Just like with variable names, just don't do it. I'm going to change this to an nvarchar. And a person's name, 50 is the default value. There may be a time when 50 isn't long enough. I'm thinking probably not the first name, but you really don't want to have to mess with this later. So let's put it as 100. And I'll say, no, you're not allowed to have nulls. Then last name, it's nvarchar. Again, for sure, 50 is not long enough for all names, because don't forget, people hyphenate their last name. So if they had a long last name and they hyphenated it, you don't want to, as a database developer, be rooting for their hyphenated name to include Jones because it's short. You want to make sure that you have enough space for them. So let's make sure you just give it 100. The nice thing about the variable character is, even though we can hold 100 if we only use 5 characters, then the other 95 aren't stored. So it actually makes our tables a little more flexible and small. So you still want to put some limits there, but you do have the option then of giving a little more buffer to your items. All right, no to allow nulls. Let's do an email address. Again, nvarchar. This one's a little trickier because I believe the actual limit here is 2,000, and that's really big. But I believe that's the limit that's put on email addresses. The reality is no one has, or practically no one, has a 2,000 character email address. But you should make sure that you have plenty of space for even extreme examples. So I wouldn't do 2,000. You could even have something on the website or whatever application you're using say, that's just too long. Pick a different one. Use a different one. Email addresses are free, or practically so. So we can definitely specify something shorter. Let's go with, let's make it 200. That seems reasonably long. And then let's add a phone number. And just like with C#, this should probably be a text character. But in this case, I don't think we need to have the N for nvarchar. We don't need Unicode characters, probably, since they're typically numbers. And so let's just do a varchar, and we will make it a maximum of 20. Now, the phone number, maybe we don't have phone numbers for everybody, or don't want to require that, so we can allow nulls for that. And then let's create another column. This column we'll call number of kids. And so we'll do an int. We're not going to allow nulls here, but we're going to put a default in. Now, probably my guess is that if we looked at every person in a reasonable group of people, the default number of kids would be 0. Because the people who aren't old enough, who aren't in a relationship or haven't been yet, as well as people who haven't had kids or whatever. So, and again, this is just an example, but we want to have a default value here instead of null, but we don't want to fill it in every time. We can put a default value right down here where it says default value or binding, and we'll set that to 0. All right, and it puts it in parens. Now it's default value when we create a new record. All right, add one more. The create date. And there's actually a couple different dates and times and other things in here. There is date, date time, and date time 2, and then date time offset. I choose to use date time too. And here's the reason why. Date is just the actual date, not a time as well, which for a create date for this row isn't good enough. Date time is the old standard for storing date and time. Date time is the new standard. So use a new standard. There's a reason for it. $3 difference. And so this get UTC date would eliminate all of that. And it's usually not a problem, but in case it is, that UTC will really save your butt. So just note that if you're doing any kind of crossing the date line where maybe you have a SQL database on the East Coast and one replicated on the West Coast, and you use both of them, that would be a problem. So in that case, get UTC date. But especially for desktop applications, that's not a big deal because you're dealing with local databases usually. In that case, get date works just fine. And I'll leave get date in. Okay, so that's it. Let's go ahead and save this. And I will call this test person table. So test person. And now I can say from my query header, let's go ahead and refresh this over here. If I were to say select star from test person, notice it's going to yell at me because I don't know who that is. If I do Control Shift R, that should refresh my well, it should refresh my window. It's not. That's okay. So what we can do is close it out and open up a new query window. Select star from test person. And now it's updated. And I can hit F5 and see there's no records in my table. And we'll get back to the query syntax in a minute. But I can also right-click on my test person table. I can go design if I want to look at it again, or I can say select top 1,000 rows, which will essentially give me just what I saw here, only if there's more than 1,000 rows, it only gives me the first 1,000. Or we can say edit the top 200 rows. Now this works great because it shows us a new editor and we can enter stuff in right away. Let's just enter Tim Corey test at corey.com 555-1212. I can put a dash there. Number of kids. I'll leave number of kids and create date blank. So right now it's yelling at me. I have not put anything for ID, and I have not put anything for a number of kids or a create date. But I filled in all the other fields, so if I hit down here, it actually creates that record. And if I were to hit the Execute SQL button by right-clicking the white space and saying Execute SQL, or by coming over here to this button right here where it says Execute SQL, a little green play button. It's going to refresh this, and notice now my ID is 1, my number of kids is 0, and my create date actually has a date in there. And that's great. Now, if I wanted to, I could come over here and say 2 kids, and I mouse off it, and that works. But if I try and change this to be 15, 4, nothing. So the reason why is because I cannot modify the primary key when it's an auto increment field. And that's by design. There is a way to get around that, but don't. Just don't. Okay? So also notice that if I were to not fill in a field where I should have, notice the first name is not filled in, it's still null. Email address is hello@world.net 555-1234. I'll leave the rest blank. If I mouse off it, it says no rows were updated. The data in row number 2 was not committed. And the reason why is because we cannot insert a value of null into the column first name. And so the insert has failed. Now, it allows it to come back here and modify this. If I didn't want to modify, if I want to destroy the row, I can hit escape. But in this case, I'll just put Jim and then mouse off it, and that works. If I hit my play button here, notice it now has a 3 for the ID, not a 2. The reason why is because we generated a 2 when we tried to enter the null for first name, last name of Smith. It didn't work, but it still held on to that ID number and said, nope, can't use that. Now, some of you may be saying, oh no, I need to get that back somehow. No, just leave it alone. Let it go. It's better that it's gone. You want to keep with the normal system that SQL does for auto-incrementing your fields. It will not hurt anything, and it will be helpful in some instances. Okay, so we've entered some rows here. A couple things to note. This editor right here edits the top 200 rows. Okay, when I said edit top 200 rows, which means that if you have 300 rows in your table, you will only see the first 200. That can be very confusing, especially if you're adding new rows and then refreshing and they disappear. They're actually there, it's just that they're below the 200 line. They're 201 or below. That can be really confusing. I've bumped into it a couple times, and there are other ways of inserting and updating rows, but it comes down to manual SQL scripts. They're not as bad as it sounds, but it's a little more complex than I want to teach you today. However, one more thing I want to show you is back here, I did this select star from test person. If you're not familiar with the SQL script syntax, actually the first thing that you should be doing is thinking about where you're pulling information from. So what I always do is I just say select star from, and then I put my table, and I'll go back and change my columns if I really want to. In this case, star means every column. Now, when you're actually creating SQL scripts and you're optimizing them for best performance and all the rest, you don't put star. Because there's a few reasons. I won't get into the whole list of them. Basically, a true SQL, developer or DBA will probably yell at you for a select star. But again, for 95% of your cases, it's probably fine. So select star is probably fine. That just gives us every row. Every column. And then since there's no limiters here, it'll also give us every row. Now, when I right click, it says select top 200 rows. How do you do that? Well, select top, 1000. Select the top 1000 star from test person. We only have 2, so it's not going to make a difference. But that would limit us if we had a million rows in this table. Whenever you're dealing with big tables, always make sure that when you're testing things out or trying queries, limit those things down to a few hundred rows. Okay, so I just hit the execute or F5, and I got my 2 records back here, my ID of 1 and 3, first name of Tim and Jim, last name of Corey and Smith, email addresses, and so forth. What else can I do with this? Well, we can also do a filter. So where last name equals Corey. Notice it's single quotes, not double quotes. So single quotes around Corey. What will that do? It gives us just the Tim Corey record. Now, if you said, well, but I'm not sure I know the full name, but I know part of the name. Not a problem. Where last name like COR %. And that's the wildcard character for, I don't know. We run that, get the same results because COR %, Corey fits in those parameters. Now, if I didn't have that % there, it's not going to find anything because last name like, without a %, it's essentially saying equals COR. So we need to use that %. Also, unlike C#, if I were to type all lowercase COREY and execute this, it still finds Corey with the uppercase C. So C# would not have found that because lowercase COREY is not the same as uppercase C, lowercase OREY. So SQL is not dependent on case. It's case insensitive. All right, so there's the select top 100 or 1000 star from test person where last name equals Corey. If we take that out, now we can take it out by either deleting it or 2 dashes in a row makes it a comment. And I can continue on and say order by, let's do a first name. So select top 1000 star from test person, order by first name. This is skipped because it's been commented out. And there you go. If you want to add that back in, we take the comments out. And now it's going to order, but because we only have one record, we really can't see if it's ordered correctly or not. But it is. So that's the basics. If you wanted to take off a top 1000 and instead of having star, say just first name, comma, last name, those are the 2 columns we want. Notice the comma separation. We execute that. Notice now that we have first name and last name. And in fact, if we wanted to, we could say as first space name, as surname. What this as syntax does is allow us to rename the column. So if I execute this, now notice first space name and surname. It kind of blends in together, but it does say surname. So we rename our columns in our queries. That's very helpful because we can separate then the display to the user from the how we store it in the database. And so we can actually hide, obfuscate, change, or improve the names of our columns right in our queries. Now again, there's so much more I can show you here, but this isn't going to be a deep dive into SQL. See my SQL from start to finish course for that. Instead, I just want to give you an overview of the syntax because next we're going to create all of our store procedures. Now, a store procedure, its job is to link together or expose a database script or a table script to the end user in some way. And so I use store procedures for just about all of my data access, in fact, all of my data access, because it allows me as a SQL developer to secure my database much more thoroughly and make sure that bad stuff does not get in your database. If you're familiar with SQL injection or all those type of attacks where people actually access from your front-end application, they access your database and destroy stuff or change stuff or access stuff, that should probably scare you. But if you use everything through store procedures and then properly secure your database, then the hackers have very little to no access to do anything you haven't explicitly said they can do. And I love that. And so whenever possible, I develop directly to store procedures, not to views, not to tables. So a view is like a query. That's up here. I typically don't use views, or at least not often. Instead, I go right to store procedures. So to create a store procedure, there's no fancy editor. Unfortunately, just right click and say new store procedure, and you get this. And that's a little complicated. Now you can take the comments out if you want. Makes it a little cleaner. That's just who created and when for what. But you still have this. I'm going to show you a little bit cleaner view that it's a little less scary, hopefully, and it actually has some relationship to our current tables. So let's go ahead and I'm going to add those store procedures in, and then I'll come back and I will show you how to actually look at them and even design them. Be right back. All right, I'm back. So I've created these store procedures here. There's, I think, 7 of them. Let's go ahead and look at this store procedure. Right click and say modify. That's probably the easiest way of looking at it. One of the benefits of saying modify here is if I say, you know what, I need to make some changes here, I can go ahead and change this in any way and run it because it's already set for alter. And so that's the first thing I'll look at. Ignore this stuff up here. And then also this right here, use tournaments, go, is just saying make sure you're in the tournaments database right up here. Because if you're in the wrong database and you add the store procedure, that's a problem. So, but we're in the tournaments database. As your parameter in your method in C#. So this is your method name. This is the parameter. This is a parameter type. So we have then the as and begin. It says begin right here and then end right here. Everything for the store procedure has to be between these two blocks, between begin and end. Again, think of these as curly braces. All right, so no count on. What that does is it doesn't send back to the caller the count of how many rows occurred. And that's fine. Just set no count on, just says don't send that extra bit of information unless you wanted it. If you wanted it, then you'd take that entry out or set no count off. But in most cases, I have not found this necessary to send back a count. Especially when you have a select query returns data. So if it returns 10 rows, guess how many rows were returned? What? 10. We can count. So there's no reason to have it send back 2 pieces of information when just one will do. And that one being our actual data. So in this one, I'm saying give me all the information from the prizes table, but then I'm joining it. And that's a little more complex. And so I'll walk you through it. Again, select, P dot star instead of star. Why P dot star? Well, I renamed the DBO dot prizes table to be just P. That's the rename right there. And that way it makes it shorter. So instead of saying DBO dot prizes dot star, I just say P dot star. Makes things a lot easier. Why P? Well, P for prize. And then I do the inner join. And what this does is it connects 2 different tables. And I'm connecting them based upon the prize table, its ID, so P.ID, equals T. T is the DBO.turnip prizes, renamed to T. So T.prize ID. It's just that same relationship we set up earlier. We're using it. We're saying this is the connection here. And then saying where T.tournament ID equals that ID passed in. So what's happening is I'm saying, let's find out the link across these 2 tables and then only give me the prizes that are in this particular tournament. Now again, it's going to take a little bit to understand that, and that's fine. If you're confused, don't worry. You just have to use this, not necessarily understand it yet. Down the road, if you want to understand it and if you want to do more with actually creating store procedures, which I would recommend, then go ahead and watch my course on C# from start to finish. So this is our store procedure. Now, how do we call it? Well, it's a little different, and there'll be a little bit difference in C# as well. But let's create a new store procedure, and then we'll call that. Since we have this, the test person table with sample data in it. So let's create, right-click on store procedure, and say, notice by the way, that is inside of the programmability folder. Then store procedure. So right-click and say, new store procedure. Let's get rid of all the stuff we don't need first. When I create store procs for my company, I actually fill this information in or create a similar template and use it. But in this case, we don't need to do that. And then let's pass in or give it a name. So I'm going to say DBO. Now, what's DBO? Well, that's database owner. Notice that all of my tables have DBO dot. All of my store procedures have DBO dot. By default in SQL Server, DBO is your primary owner and primary schema for your tables and store procedures and views. You could change that, and in fact, if you use a sample from Microsoft, you'll see all kinds of different schemas. Instead of DBO, it'll be person dot or address dot or company dot. That gets a little confusing, and again, for a rookie person just starting out with SQL Server, don't worry about it. Put everything in DBO. So create procedure DBO dot. And let's call this. I always start with SP. Don't do SP underscore, but SP. SP underscore will confuse the system into thinking this might be a Microsoft supplied store procedure. And that's not good. It makes things longer to try and figure out, and it could have some naming issues. So let's call it SP test person underscore get by last name. Now parameters, Let's just go ahead and wipe all this out. And let's wipe out this comment as well. And we will wipe out this as well. So it's a little more bare bones. Now, in the parameters here, I want to bring in one parameter, and that would be last name. Because I'm going to get the test person by their last name. If there's more than one person with that last name, it'll bring more than one record back. So we will say at, because all variables in a store procedure should start with at, last name, we'll say space, and varchar 100. Now, if you're not sure on the number, how big your last name should be, you can right-click on test person, go to design, and say, yep, last name was 100. You could specify in your store procedure less than the maximum. If you specify more than the maximum, you'll have a problem when it comes to inserting. So, but less than is fine. Equal to is probably the best, since it's the same limitation, but it's really up to you. So last name, or at last name, space, and the type. If we had more than one, we'd put a comma here and say at, say first name or whatever. But in our case, we only have one parameter being passed in. And then down here inside our begin, before our end, we will say select star from dbo.testPerson. Now, do I need to do dbo dot? Technically, no. If I don't, then the system will say, I'll think it's probably dbo. And so it'll assume that and prepend it. But in this case, it's probably just a little cleaner to say dbo.testPerson, where last name equals at last name. I'll put my semicolon to be complete. And we're done. That's our store procedure. I hit execute, and it says commands completed successfully. And at first, you might be thinking, if you're not, if it's late or whatever, you'll think, wait, what? Why don't I see data? And you don't see data because this doesn't do data yet. What you're doing is actually creating a new store procedure. You're just creating a new entry here. If we hit refresh, you will see that test person get by last name is right there. And if we create a new query window, I can call this by saying exec dbo.sp test person underscore get by last name. It's not there, so it's going to yell at me, so I have to refresh. And that's the Control-Shift-R, so that takes a bit. And I can say Corey. Now, even if the squiggly is there saying, nope, didn't find it, you can still run your query. It will still work. It's just that the editor hasn't caught up to the fact that there's new objects. That Control-Shift-R will do the refresh. It'll take a couple seconds. As you saw there, it took, 15 seconds or so before it actually refreshed our editor. Closing and reopening also works. So I'm saying exec, that's how you execute a store procedure. The name of the store procedure, the full name, dbo.sp test person underscore get by last name. Case sensitivity is not a factor here, so it could be all lowercase if you wanted to. And then after a space, I put my parameters, and I can either put them in order, or I can say at last name equals like so, and then comma separate them that way. I guess you should do them in order, and that seems to be fine for me. If you hit execute, notice it now says Tim Corey. And if we look up, I forget what the other person's name is, so you can select star from, and it's Jim Smith. So last name was Smith, and we execute that. Now Jim Smith is down here. So based upon what we select up here and run is what we get down here. So that's how a store procedure works. Now, one thing I haven't pointed out yet in the editor window, if I have this highlighted and I hit F5, look what happens. Could not find store procedure Smith. So you saw, again, this took over an hour to kind of give you a good overview of what's going on. But I thought it was important for you to get a good handle on things before you get into actually using this. Now, I don't want you to feel uncomfortable about later going into this and just poking around, seeing what you see, trying things out. Maybe you don't get as complex as store procedures, but maybe you can create a new table, try it out, maybe even try linking two tables together. I want you to feel comfortable at least seeing this data and seeing this data coming from SQL and not being concerned that it's a black box. All right, coming up next, we're going to get back to C# and look at the logic for our prize form. It's a pretty simple form. We're going to see how to hook things up, and we'll get into some data access and setting some of that up and continue on from there. So that's what's next.